Have you ever just stopped and looked around? I mean, really looked at the world we've built? Your car, the buildings downtown, even the fridge in your kitchen. They're all packed with complex metal shapes. And pretty much all of them started their life with one amazing, deceptively simple machine. So let's dive into the hidden world of the press brake.
So how in the world do we get from a totally flat sheet of steel or aluminum to the complex, three-dimensional parts that literally hold our world together? How does a factory make something like,
well, like this electrical cabinet? I mean, look at all those perfect angles and clean edges. It has to fit together exactly right to protect all the sensitive electronics inside. Or what about a part for a car chassis? This thing needs to be unbelievably strong, but also light. Every single bend you see is carefully engineered for structural integrity, for safety. Or think even bigger, like a massive architectural panel on a skyscraper. Every single bend contributes to the building's final look, its strength, and its safety. The answer to how all of this gets made, it lies with one essential machine.
it's called the press brake. You know, this machine is one of the oldest, most versatile, and most critical tools in any fabrication shop. But most people have never even heard of it. It's truly the unseen hero of modern manufacturing.
At its core, a press brake is elegantly simple. You've got a punch, which is the top tool that moves down, and a die, which is the bottom tool that just stays put. The machine applies a massive amount of force, squeezing the metal between them to create a permanent bend. That's it.
But to really get how it works, we need to geek out for a second on the science of what's actually happening to the metal. It's not just about brute force, it's all about controlled deformation.
The whole goal here is to achieve something called plastic deformation. See, when you first apply a little pressure, the metal flexes. That's called elastic deformation. If you let go, it would just spring right back. But when you push past the material's limit, you permanently rearrange its internal structure, and that is the bend. You know, think about bending a plastic ruler. You flex it just a little and it snaps right back to being straight. That's elastic. But if you bend it too far, it gets that permanent white crease where it just breaks. That's plastic deformation. The press brake is an expert at pushing the metal right into that permanent plastic state, but without ever breaking it. Now here's where it gets really clever. What do you think happens the exact moment the punch lifts away from the metal? You'd think it would just stay put, right? Well, not exactly.
It actually has a tendency to spring back. Yep, because some of that elastic energy is still stored in there, it tries to straighten out just a tiny bit. This is called spring back, and it's the single biggest headache in precision bending. To deal with it, modern machines will actually overbend the part just slightly, knowing it'll spring back to the perfect angle. It's an incredibly smart piece of engineering.
Okay, so we've got the science down. Now let's take a look at the machine itself. A modern press brake is a seriously sophisticated piece of equipment, with several key parts working in perfect sync to nail that perfect bend every time.
First, you have the massive frame, which is built to be incredibly rigid. Then there's the backgauge, which is like a set of robotic fingers that precisely positions the metal sheet for each and every bend. You've got a crowning system to make sure the machine doesn't sag in the middle on long parts. And of course, the CNC controller. That's the brain that runs the whole show.
These days, press brakes are usually one of two types. You've got your hydraulic ones. They're the power lifters, known for raw power, perfect for thick, heavy stuff. Then you've got servo-electric brakes. They're all about speed, energy efficiency, and incredible precision on thinner sheets. So you might use a hydraulic press for a big truck frame, but a servo-electric one for something delicate, like a computer case. But the real art and science of bending, that all comes down to the specific tools and techniques you use. This is where a skilled operator really earns their stripes. There are two main ways of doing it. Air bending is the most common. The punch just pushes the metal partway into the die, creating a three-point contact. It's flexible and uses less force. Bottom bending, on the other hand, literally squishes the metal all the way into the die. This takes more force, but wow, is it precise. And the tools themselves are where the real problem-solving comes in. The punch, that upper tool, comes in all kinds of shapes. Let's say you need to make a bend right next to another one that's in the way. You'd use a gooseneck punch to literally reach around that obstacle. Need a super sharp corner? That's a job for an acute angle punch. And to create a safe, smooth, folded-over edge, you'd use what's called a hemming punch.
Of course, for every punch, there's a matching die waiting below it. V-dies are the all-purpose workhorses you see everywhere. Hemming dies pair up with hemming punches to make those safe, folded edges. And then you have these clever designs, like the multi-V die,
which is basically a rotating block with a bunch of different V openings, and that saves the operator a ton of setup time.
So, after all these technical details, let's zoom back out. Why is this one single machine so incredibly foundational to our modern world?
Well, the simple answer is that almost every major industry you can think of relies on it. From the rockets we send into space, to the cars we drive every day, to the air conditioners keeping us cool, the press brake is in there somewhere. If it's made of shaped metal, there's a really good chance a press brake was involved.
This quote from our source material just nails it. It's the ultimate multitasker of the metal shop. It can be making a simple bracket 1 minute and then a complex aerospace part the next, often just by changing out the tools.
So when you boil it all down, it just comes back to this one idea. One type of machine doing one fundamental process is responsible for an incredible amount of the world that we see all around us. It's the quiet cornerstone of modern manufacturing, shaping our world one precise bend at a time.
You know, this machine is the perfect blend of old and new, the raw power of hydraulics combined with the pinpoint accuracy of a computer. It's one of the most indispensable tools we have, quietly making so much of our technological progress possible. So the real question is, what are we going to use it to build next?